Hi everyone. Okay, derivatives of functions is what we were going to do today, and it should look very familiar. What we have been doing is we find that general form of the slope of tangent lines for functions. What you're actually doing, look at that, limit of h approaches 0 is f of x plus h minus f of x over h. That is what the derivative, and we use the notation for derivative is f prime of x. So the derivative of f at x is given by f prime of x. That's what the notation for derivative is. And you've seen this before. So we're not doing anything new. We'll get more practice, but now we're calling it the derivative. That's the big difference today. So for the following functions, find the derivative. Okay, f of x equals 4x squared minus 5x. So we want to find f prime of x. That's the derivative. And that means we have to take f of x plus h minus f of x over h. And we also have to find the limit as h approaches 0. That's important. Alright, so let's do that then. For x plus h, I'm going to take 4 times x plus h squared minus 5 times x plus h. And that is the f of x plus h part. Then I'm going to subtract f of x, which is 4x squared minus 5x. And I'm going to put all that over h. I need to deal with that part a little bit. And I got 4 and then x squared plus 2xh plus h squared. Okay, you can FOIL it out if you want, but if you remember the properties for squaring a binomial, I would encourage you to do that. And then I've got the distributive property. I'm going to go negative 5x and minus 5h. Almost forgot to write that 5. Minus, I'm going to go ahead and just get rid of parentheses there. 4x squared minus and a minus, that's plus 5x squared. That's one of the things I might have been noticing as we go through these. And I also noticed that I always forget to write that limit in them. So maybe a double negative, that plus there, that's going to come into play here pretty soon. Let me write one more step and then we'll start combining stuff. I don't think I need parentheses anymore. 4 times x squared plus 8 times xh plus 4 times h squared, and then minus 5x and minus 5h. So I distributed the 4 for those three terms. I still had that part. And then minus 4x squared. Okay, that would have made a difference. Okay, take that square off if you were just copying down what I was saying, because I just discovered that that shouldn't be there. Over 5x, or plus 5x, sorry, over h. Okay. Is there some canceling happening here? I see a negative 4x squared and a positive 4x squared. And I see a negative 5x and a positive 5x. The limit as h approaches 0, I've got 8xh plus 4h squared minus 5h. That looks like about it to me. Over h. Okay, I'm still going to keep the limit until I get this factored out. They each have an h. So let's put that out here and go 8x plus 4h minus 5 over h. And then cancel out those h's. And that's the limit as h approaches 0 of 8x plus 4h minus 5. And now I'm going to substitute the 0 in for the h, and that becomes 0 there. So 8x minus 5. The derivative of f of x is 8x minus 5. And that's all we're after today. Just finding the derivative. And then, you know, in the last lesson we might have had a couple points and said, well, what is the slope at those different points? We're ready wherever you want to look on this function, whatever values of x, where you want to look at what the tangent or the slope is of the tangent line. You'll just plug it into there. Okay. Next example. Now we have a square root function here. F prime of x is the limit as h approaches 0 of f of x plus h minus f of x over h. And okay, so I'm going to put the x plus h. So the f of x plus h, I got to do the square root of x plus h, and then I still have that plus 1 out there, minus the square root of x plus 1. So this part is the f of x plus h right here, and this is just plain old f of x, and that's over h. Don't forget your limit as h approaches 0. Alright, let's get rid of parentheses and just see what it looks like here. So the limit as h approaches 0 of the square root of x plus h plus 1 minus the square root of x plus 1 whoops, not plus 1. I forgot to write the plus 1, and then this is a minus, and this also is a minus. Let's keep that good. So that cancels and that cancels. This is the limit as h approaches 0 of the square root of x plus h minus the square root of x, and that's over h. Alright, at this point, I can't get this h to cancel out with everything. So what I'm going to do, I think our trick with square roots is to rationalize the numerator. So the conjugate of the numerator is the square root of x plus h plus the square root of x. This is just a necessary step here. Square root of x plus h plus the square root of x. And at this point, if we go ahead and multiply this out, I've got the limit as h approaches 0. Now I'm going to multiply, and it's just going to be this squared minus this squared, because this is positive, this is negative. The outside-inside part of foiling would cancel out. Now the square root of x plus h times the square root of x plus h is x plus h. And then negative square root of x times positive square root of x is negative x. The square roots just cancel out. When you're squaring it, you're multiplying it by itself. And then let's put this over h times the square root of x plus h plus the square root of x. And let's take a look what happens here. This x and negative x cancel out. Let me keep my limit here. Limit as h approaches 0 of h over h times the square root of x plus h plus the square root of x. Alright, that worked, because that h now does cancel. That h in the denominator is canceling. So I've got the limit as h, sorry, not x, as h approaches 0 of 1 over the square root of x plus h, I don't need those parentheses anymore, plus the square root of x. Now it's time for substituting. And I got 1 over the square root of x plus 0 plus the square root of x. I'm not doing the limit anymore. I did the substitution. I'm finding that actual value now. And that would equal 1 over square root of x plus square root of x. And those are like terms, so I'm going to make 1 over 2 times the square root of x. So that is f prime of x. Okay, I have one more example. I've gone kind of long here. I'm going to put it on the next video.